Hello, guys. Now, a complex numbers can be written in either Cartesian form, polar form, exponential form. So in Cartesian or rectangular form, this is how it's represented. It's represented as z is equal to x plus jy, where x represents the real part and this other part is the imaginary part. Now, in polar form, it is written in the form r cos theta plus j sine theta, or simply as z is equal to r with the angle theta degrees. And in exponential form, it is represented as z is equal to r exponential j theta, where theta has to be in radians. And this is the conversion from rad to degrees. Now, when you're given a complex number in Cartesian form, you can change it to polar and vice versa. So we want to look at conversion from Cartesian to polar and vice versa. Now, let's first of all look at Cartesian to polar. Now, in order for us to carry out the conversion from Cartesian to polar, it's important for us to know how to draw an Aggregate diagram. So an Aggregate diagram is basically a pictorial representation of a complex number in the Cartesian plane. Let's say you're given a complex number like 3 plus 4j. 3 plus 4j, and you want to represent this in the Cartesian plane. The x-axis, and this is the y-axis. This is the y-axis. So this basically is represented on the x, and this is represented on the y. The real part is represented on the x, the imaginary part is represented on the y. So representing 3 on the x-axis, so let's say 3 is somewhere there, and then 4, positive 4, let's say there. So our complex number, the point 3, 4 will be somewhere there. So basically, this will be the representation of the point 3, 4. Now, whenever we are carrying out conversion from Cartesian to polar, it's important for us to make this particular sketch so that we know in which quadrant exactly that complex number lies in. That will help us be able to evaluate the angle. So this is obviously the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And then the other thing we need to know is how to get the value of r and theta, because if we are converting a complex number zx plus jy to polar, we are changing it to z r theta. So we need to know how to get r and we need to know how to get theta. Now r is simply given by x squared plus y squared square root, and theta is given by tan inverse of y over x. Now, I want us to take up simple examples and see how exactly we can be able to convert from Cartesian to polar. So let's start with the first example, conversion. So we are converting z is equal to 3 plus 4j to polar. So I'll say the first thing is we come and make a sketch. So making a sketch, x-axis, y-axis, 3, this will be in the first quadrant. So what is our r? R is x squared plus y squared square root. So that is 3 squared plus 4 squared square root. What is our theta? Our theta is tan inverse of y over x. So what will this give us? This will give us 5. And if we evaluate this, this is 4 over 3, not x. And if we evaluate this, tan inverse of 4 over 3, this will give us 53 degrees. This will give us 53 degrees, roughly 53 degrees, because I don't have a calculator. So yeah, so 53 degrees. Now let's take up a second example. Let's say z is equal to, so you're given z is equal to, let's say, minus 3 plus 4j. We come and draw a rough sketch of this. The x-axis is minus 3, so minus 3 will be on this side. Let's say minus 3, and then the y-axis positive 4. So let's say positive 4. So that complex number will obviously lie in the second quadrant. So coming to evaluate the value of R is given by -3 squared plus 4 squared square root. And that will give us 5 if we evaluate. And theta will be given by tan inverse of y. Our y is -4. All this divided by x, which is 3. And this will give us -53 degrees. This basically shows us that the quadrant in which it lies in, the tan is negative, i.e. if you have these quadrants, add sugar to coffee. Here, all the trigonometrical identities are positive. Here, only sine is positive. Here, only tan is positive. And here, only cos is positive. Now, as we can see, it is in the second quadrant. And here, tan is obviously positive. Now, since it's in the second quadrant, how do we get the angle in the second quadrant? So, in the first quadrant, the angle is just gotten by theta. The second quadrant is 180 minus theta, where theta is the small acute angle. Here and here, it's 180 plus theta. And here, 360 plus theta. So what will be our angle here? This will be 180 minus 53 degrees. Okay, we are not taking this minus here because this basically just says that it's tan, and tan is negative in that second quadrant. So 180 minus 53 degrees, that will give us about 126 degrees. And in polar, so I didn't write this. This in polar is 5 and the angle is 53 degrees. This one in polar is 5 and the angle is 126 degrees. Okay, fine. So example number 3, let's say we have -3 minus 4j, -3 minus 4j, and then we are being told, so this is the value of our z, to convert this to polar. So we come and do a sketch for this. -3 on the x-axis is obviously on this side. -4 on the y-axis will obviously be here. So obviously this angle lies in the third quadrant. What's the value of our r? R is -3 squared plus -4 squared square root. Okay, this will give us 5. And theta is equal to tan inverse of y over x. So that is -4 over -3. And this will give us 53 degrees. So since it's in the second quadrant, the third quadrant, sorry, how do we evaluate angles in the third quadrant? 180 plus theta. So the angle here will be 180 plus 53 degrees. And that will give us what? 180, if you take 180 plus 53 degrees, so that should give us about 233. So 233 degrees. So in polar form, we will have it as 233 degrees. Finally, let's say you're told to convert 3 minus 4j. So 3 minus 4j. You come and do a rough sketch of that. 3 on the x-axis will be this side, positive, -4 will be this side. So obviously that particular complex number will be in the fourth quadrant. How do you evaluate r? 3 squared plus -4 squared square root. And this will give us 5. How do you get theta? Theta is tan inverse of y, which is -4 divided by 3. And this gives us -53 degrees. But it is in the fourth quadrant. So how do you get the angle in the fourth quadrant? 360 degrees minus the theta, so -53. And that will give us about, so if we evaluate the last part, that should give us, okay, 360 minus 53, so that will be 7. And then, okay, so 703, about 307 degrees. So in polar form, we will have it as 307 degrees. That's it, guys. It's very important that whenever you're converting from Cartesian to polar, you do the sketches. However, how do we go about now converting from polar to Cartesian. That's quite straightforward. So what you need to remember basically, so from polar to Cartesian now, what you really don't have to do any sketches. All you have to remember is that the value of x is given by r cos theta, and the value of y is given by r sin theta. That's it. So let's say, for example, we just take up what we did in this other section. So like the first one, we had 5 and 53 degrees. So we want to convert this back into Cartesian. So what is it going to be? So you have your z is equal to 5, and the angle is 53 degrees. So to convert to Cartesian, what you do is get the value of x and y. X will be equal to r, which is 5 cos of 53 degrees, and y will be equal to 5 sine of 53 degrees. And if you evaluate that, you will get your answers for x and y if you put that into the calculator. So you will have your x as 3 and your y as 4. So you will have your x as 3 and your y as 4. So basically your z will be equal to 3 plus 4j. And similarly for the rest of the values, converting to Cartesian from polar, you just write this. Now, the same way, if you want to convert to exponential form, this is, you're just getting the value of r and theta. So it's more or less the same as converting to polar. However, the only difference is that now your theta has to be in rads. So for example, let's say you're given a question 553 degrees. This is in polar, and you're required to convert it to exponential. It's already in exponential. The only thing is that this theta needs to be in degrees. So 1 rad is equal to 57.3 degrees. So what about 53 degrees? So you evaluate that, that will be 53 degrees divided by 57.3. Whatever that will give you, then your answer in exponential will be r, which is 5 exponential j theta. And your theta is this, 53 over 57.3. You simplify that. So basically just writing this in rads will give you your answer. So if you are given a question that is in Cartesian and you're being asked to convert it to exponential, first of all, just convert it to polar so that you get your values of r and theta. After getting your values of r and theta, you already have your answer. You just convert this theta to rads. And that's it for conversion, guys. That's it for conversion.